We're at this road cut here in the Coast Range near the Willamette Valley. And the spot we're in is rather interesting. We've driven up here through places where we saw lots of road cuts with red soil, like this. Well, at least something like this. This is a particularly nice exposure of it. Got a little scale thingy here from GSA. First thing you might wonder about is what's making these holes here. That would be bullets. This is a popular shooting spot, apparently. Skeet. I like this place because we're technically right here. I'm still within the watershed of the South Fork Alsea. But if I throw a clod of dirt over there, that's in Target Canyon. Target Canyon is wicked steep, and South Fork Alsea is not so steep. It seems steep unless you're familiar with the really steep stuff. You might have, a few of you might have gone mountain biking, some great mountain biking trails at near the Alsea Falls. And they're great because they've been able to carve them in this weathered stuff, right? This will form a nice banked curve. It'll make a nice table jump, all that great stuff. Now, this weathering horizon, from the top there down to the rock here, I measured with students a couple years ago to be 4 meters. So we've got 4 meters of red soil up there. And then right in here, you can see we go from here where the chunks of rock are floating in the matrix, and then down to here where the rocks appear to form layers. Now, it's not, this isn't the most obvious spot to say that's onion skin weathering. But once we start pulling out little chunks, this here is about 1 centimeter thick. I'll pull out some random other chunks kind of. Thing is, this is saprolite. If, I pick up a random chunk of rock, I can crush it with my fingertips. So this is highly weathered. We need to get down a little ways into this rock. Probably around where my leg is. That's now stuff that I can't just mess up with my fingers. Technically, that's something like real rock. But it's kind of hollow. Pretty porous. I'm going to throw a number out there. I'm going to say that the bulk density of that is around 2,000 kilograms per cubic meter. That's not a guess. I'm actually getting that from the literature. So anyway, this is a really cool spot for me because, this is a really thick weathering horizon. Our next spot we'll go to is also has rhinelet formation. But the soil is a lot thinner. Now, one of the things I'm asking is how thick are these rhinelets here? So here we have centimeters and a piece of a rhinelet. And so it looks like, the rhinelets are a little more than 1 centimeter thick. All right, I get more than one part of another rock that appears to be a bit of a piece of a rhinelet. This one here looks a bit thinner, but also pretty close to a centimeter, maybe a little bit less than a centimeter. I'll pull out easily enough. One with not so coherent, so you know, it may be that some of these are breaking into thinner rinds than others, and this one seems to be about half a centimeter thick. Again, this is fingertip crushable. Pull stuff out of here. Way oxidized, so red. This one, interestingly, a chunk from up here in the soil, is not as rich in clay minerals as this stuff that's going past me. So, evidence that there is still some bioturbation that is pulling up intact rocks into the soil horizon. This degree of redness, I showed a picture of this road cut to Josh Roaring at University of Oregon, who's done a fair amount of some kind of dating of these soils to try to determine their age. This red is about 100,000 years. I was wearing kind of a reddish shirt, and he pointed at that, and he said, that red, that takes 1,000,000 years. So this is not the oldest kind of red stuff that we see in the Coast Range, but it's aged nonetheless. And it's going to be, in terms of transport processes and so on, what's moving stuff around, well, we don't have to entirely speculate. If you can pan around to, there are various things dangling, but in particular down here, I do see some roots actually sticking out of the soil. It does appear that some of these trees have roots that will penetrate to kind of arbitrarily deep points, at least within the soil. Right here, I just want to sort of marvel at the thickness of this soil. But at the next place we go, the soil's not going to be anything like this thick. 4 meters is a very thick soil for the Coast Range, at least within the Tyee Formation. This is the Tyee Eocene Age Tyee Sandstone, or Tyee Formation, which is rhythmically bedded or interbedded sandstone and mudstone. As you get further north in the formation, the sandstone beds get a bit thinner and the mudstone beds get a bit thicker. Yeah, so let's see. We have bullets, redness, weatheredness, and getting down to intact rock doesn't take all that far. I guess that's about 10 centimeters there, and still in pretty clay-rich stuff. When we break open the fresh stuff, it's got a real light gray color to it. It's something you can sort of see occasionally. Well, like this piece here, you can see this is a very light gray. Honestly, I don't know what gives it that color as opposed to a red. I might speculate that it might be some kind of ferrous iron.
I wanted to give you a little bit, just a slightly bigger, broader context here. So there's the tripod still set up where we just were looking at the little outcrop of the weathering horizon. So there's our red soil, and you can see the relatively gradual slope of that there, and then we're looking off that way. Kind of hard to see with the picture, but relatively, it's still hilly and whatnot. It's not all that steep. Okay, so then come over here, and then, geez, right about like red and not red, and literally just like right next to it, we've got rock up here. Definitely hard to tell how far up above that there's rock, but definitely, like over here, the rock is way down here, and then it's way up here. And so, yeah. We will, for our next stop, go down this road here to a place where we can put our hands on the soil and see a good outcropping of the rock, the weathered rock. But it's also interesting right here to show you what I alluded to was just how steep it is just right here. And it's hard to get a sense for that. If we get lucky along the way, we might get a chance to demonstrate the steepness. The problem with the Coast Range is that you take a picture of it and it comes out green. If you were here with your binocular vision, you could get a better sense for this. But this slope just drops off, and I've measured the slopes of a few of these kinds of hill slopes, and they come out around 40 degrees, usually 40 degrees, 40, 41, 42 degrees. Interestingly, the angle of repose of the unconsolidated soil material is about 37 degrees, so that's a bit of a puzzle. Anyway, that's it for now.
So here we are at a different outcropping. This is just down the road from the previous very thick red soil horizon. Now we can see that we are definitely dealing with sandstone. And it's not all clay. It's not really what the completely unweathered rock looks like, but it's got kind of a yellowishness to it. And up here you can see that we've got trees right here. And it's hard to tell exactly how thick the soil is, but we can see that it's a whole lot thinner than it was at that previous stop. Now, what we can also see at this spot are some rhinelets. And I'll reach in here at the risk of making everything worse and see, oh yeah, check that out. Here's a rhinelet. So we can measure some thicknesses of some of these rhinelets and see that we're dealing with, I guess right there I'd put that at about 1.5 centimeters, give or take. And I can measure a different spot on the same rock. A little more than 1.5 centimeters. Let's see, let's find one from a little bit further down in the profile, and maybe the broken edge there. A little bit variable, but if I go to this relatively thick part right here, see that again, we're talking pretty much the same thickness, about 1.5 centimeters. So potentially these rhinelets are a little bit thicker than at the previous stop, although, I don't know, maybe not all of them. Here's one, a little bit thinner, a little bit more than a centimeter thick. Let's see, a layer here. Oh, yeah. Okay, yeah, so some of these are a little bit thicker. Not that I would know what that means, if anything. You can see that's about 2 centimeters thick right there. It's not uniform all the way across, but reasonably consistent thickness. Ooh, sun's out, so you can see the little bit of sparkly from the... this is a micaceous sandstone. Still pretty crap rock. Again, I'm going to call that about 2,000 kilograms per cubic meter density-ish. Once we get down into the unweathered rock, the density would be greater than that. This is weathered enough that there is mass missing, and so it's not as dense as the intact rock. I just pulled another bit of rhinelet out from over here, from a spot where it looks like the rhinelets are a little bit thinner than the one I was looking at before. This one, just about a centimeter thickness, but again, it's somewhat variable. Some of it a little bit thinner than a centimeter, right there. So, some variation in thickness. But so far, it looks like everything we've seen is thicker than a ½ centimeter and thinner than 2 centimeters. So, not a huge range of sizes. Oh, check that out. Might as well look at something pretty. There's some green in the rock there. I'm assuming that's copper. I don't know anything else that makes that green. I wanted to try to find a spot where you could get more of a sense for what the soil looks like. It's so thin that it's just hard to find a place where you can see it, really. What do we got here? We got some held together with roots. Probably mostly organic material. About 3.5 or 4 centimeters thick. Below that, oh, well, we're down into more organic stuff. So really, when it comes to soil, that's rock, and that's the forest floor. So we're really talking about a thickness that's, you know, about 10 centimeters. So we're at about, so we're like probably less than or on the order of about 10 centimeters here. Now, maybe if I went up on the slightly less radically sloped part here, I'd get up to maybe 15 centimeters thick. I think if you tried to measure it with a measuring tool other than something like this, you'd come up with something like 15 centimeters thick. But, you know, something in that range, 10 to 15 centimeter soil thickness. About as thin as soil gets, so-called soil. It's definitely soil. I mean, I've been sort of characterizing it as a pile of gravel, and there's definitely gravel in there, but it's very organic rich. Lots of mineral in it too, right? Not just iron and aluminum. It's just not given a lot of time. So this is pretty much a faster moving soil horizon. So the soil doesn't have very much time to get red before it's gone. So we've come down from that landing we were on, down into the woods a ways along what we call a cat road. Would have been something they cleared with a tractor for logging. What I'm standing on here is older than the trees. You can tell that because some of the trees are actually growing on it. What is it? Well, I'm standing on a mound here, and there's a pit up slope of this. So we've got a pit upslope of a mound. Off to your left, my right, is a log, if you could call it that. It's probably very old. A lot of it is missing. But it ends right where I'm standing. So, what am I standing on? I'm standing on a big pile of roots. At some point, this tree fell over, ripped up a lot of earth with it. As the roots decayed, soil fell out of the roots and just settled into this mound. If we try to envision how that might, over time, if we repeat that process, how we can move serious volumes of soil around, it just takes a long time. If you think in terms of the roots of the tree falling kind of downhill, it's going to fall down slope. Those roots and whatever's attached to them are going to get lifted out of the hole, up out of the hill and over. And then when the roots decay, the material's going to fall out of the roots straight down outside of the hole. So all that stuff that was in the hole has now been moved out of it and down slope. Because if the tree fell up slope, then it would only fall so far. It would stop against the slope and the roots. So the roots would only get pulled like that much out. And as the roots decay, the stuff falls back into the hole. So trees that fall downhill take the stuff and move it downhill. Trees that fall uphill don't. So think then, repeat that many times, and you move some soil around. As well as bringing unweathered material up from below and exposing it to more weathering. Hey Logan! Logan's been our cameraman today, and there's the tripod where the previous shots were aimed from. So there's the pit that he was looking down into. I don't know, maybe on this it just looks green. And here's the top of the mound that I was standing on and am standing on right now. And what I wanted to show you, if you can see it even through the green, is that there's a
a log that went off this direction. I can really only see the definite log out to about here. Past that, it's hard to say with much certainty, but I can see it here, and that it ends, of course, about where I'm standing. And now there's also another log over here, see right there, and it ends somewhere in here. Don't know whether it was there before when the other one fell over, whether they fell at the same time or not. But you know, it's kind of neat that on the downslope side of this mound, there's like several meter pretty much drop. Like if I were foolish enough to take a leap, I would probably break some legs, some bones or something. You can see maybe down there, looks like there's maybe another pit and then a mound. And so this is, you know, obviously not a process that works on that daily scale like perhaps the gophers, or even a yearly scale. It takes a long time for a tree to get big enough to get blown over, because that tree needs to do some dying, needs to get sick probably in order to fall over, in order for enough of the roots to break for the wind to pull it free. And as far as we can tell, we being, again thinking of Josh Roaring's work, he's looked at how old are the trees that fall over. We're talking definitely more than 40 years, maybe 80 years old before you get to trees that are big enough to fall. And just for reference, typical rotation intervals for forestry in the Coast Range are on the order of 40 years. So, you know, that's conceivably a problem for long-term soil development, that harvesting trees before they're old enough to die is going to stall the process that creates the soil in which the trees grow. Now, it'll probably take a long time for that to come to anything that makes much of a difference in anybody's life, but it's a thing, maybe.